Hello friends, this day I want to do a project that I think will be fun. I hope you will have fun too. First, let's start with the materials. I used the Arduino Uno set. Apart from the Arduino board, I need an HC SR04 ultrasonic sensor, 28 BYJ, 48 stepper motor and driver, 2 PH124959A, breadboard, and necessary cables. I did not use the small breadboard in the video. First, let's make a stand to mount the ultrasonic sensor on the stepper motor. I think there are ready-made stands for this, but since I didn't have one, I made it out of PVC. You can also use hot silicone to glue the parts. I preferred super glue. I recommend you to be careful when using glue. If the glue touches something you don't want, it can be cleaned with acetone, but I would still use it carefully. Now let's try it on the bike. I think it's fine. Then we'll move on to the cable connections. I'm using this kind of stuff because I'm doing this system temporarily, but you can make it better quality if you want. First, I wanted to make a chassis for the installation, but then I decided to build it all on breadboard. fix the Arduino board, stepper motor, and driver on the breadboard. The red wire is connected to the 5V output on the Arduino, the black wire to the G&D pin, and the other leads to the breadboard plus and minus lines. I used the same red and black wires for the power connection of the stepper motor, and the motor receives 5 volts plus and G&D from the Arduino. I connect the 5-volt wire to the VCC pin on the drive, and the G&D wire to the G&D pin on the drive. To control the stepper motor, I connected the N1, N2, N3, and N4 pins of the driver to digital pins 2, 3, 4, 5 of the Arduino. Now let's connect our ultrasonic sensor. There are 4 pins on the sensor: VCC for 5 volts, G&D for negative line, trig, and echo pins. The sensor generates and detects ultrasonic sound waves through trig and echo. These sounds are inaudible to the human ear, and we can use the return of these sounds from the sensor by hitting any obstacle to obtain the necessary data such as distance. I connect the white wire to VCC on the sensor and 5 volts on the Arduino, and the brown wire to the G&D pins. Then I connected the yellow cable trig pin to digital pin 8 on the Arduino, and the green cable echo to pin 9 on the Arduino. We have completed the connections, and now it's time to write the code. I prepared the code part in advance so that it would not take much time. Let me briefly explain what I wrote. At the very beginning, we need to inform Arduino about the pins we connected the stepper motor to. We also define the trig and echo pins of the sensor. Then we determine in which order the pins of the stepper motor will be active. We need to transmit this to the Arduino step by step. On the 4 pins, we write such a combination to send the output signal in order. If this order is not correct, the motor will not work. We defined the motor pins in the trig pin of the sensor as output and the echo pin of the sensor as input. Once the definitions are finished, let's tell the Arduino how to make a loop. We write the necessary codes to calculate the data from the sensor and convert it into a visual graphic. With this code, Arduino can calculate the speed of sound and the distance to objects. We also need to translate this process into a visual interface. For the visual side of things, I used processing. The code here is very long and complex, so I won't go into details. In the future, I will add all the codes I use to the description so you can use them, and you only need to pay attention to 2 things here. First, correctly write the port you plug the Arduino into in this field. You can find out which port by going to the Arduino IDE in the Tools tab. If you get a font error afterwards, select the font you want from the Set Font section in Processing's Tools panel and paste it in the relevant place. The error will go away. Once everything is set, we can start the animation. For this, we press the Run button on the top left. Make sure that the serial display is off on the Arduino so that processing can run. Thank you for watching. Don't forget to subscribe to the channel and turn on notifications for more of this kind of content.